All right, I'd like to convene the engineering committee on August 19th for the San Lorenzo Valley Water District. Lee, would you please take roll?
Bob Russ,
Here.
Ray Grau,
Here.
Francis Cleveland,
Here.
and Bill Grace.
Here.
Thank you.
All right. There any changes to the agenda?
No.
No. Okay. Anybody online for oral comments?
No.
Okay. Then we'll jump into the district water loss analyses, I guess. All right. So who's going to take that on?
Jeff will start us off.
Okay.
Start us off.
But you did the audit, so you can best give the background for it.
Okay, yeah, so a couple months ago, we completed the water loss audit for the SLV and SLV Pelton systems. This is required from the state to do every year. It takes our production, it takes our consumption. It factors in meter accuracy testing, which we did not have last time. We did it for the fiscal year 2025. We did not have that in 2020. We did not have any during that time frame. We didn't do any meter testing, so that did impact our score. Good news is for the next water loss audit, we tested 421 meters since then, so that will be implemented on the next water loss audit. So that should improve our score, but you know, the water loss audit is, like I mentioned, it's mandated by the state. It's hard to really identify exactly what our true losses are. Basically, there's apparent losses and real losses. Real losses would be main breaks and actually water on the ground, and then apparent losses would be meter inaccuracy or just errors in recording or whatnot. So with the first look at it, it does look like we have a lot of water loss, 20-30%. That being said, I would say a lot of it come from inaccurate meters. So we're trying to aggressively replace those. And there's also a report called the SAFER report that we do monthly that the state also requires, and that takes a look at individual sources. We do have an issue with the SAFER report with our Intertie 6. It moves water between our Felton and SLV system. So technically we're moving water in between two separate systems. And the state looks at that as imported and exported water, but it kind of skews our, what happens is it skews our overall, the way SAFER does, and we don't have full answers. We're still trying to figure it out. So we've kind of shifted gears to just looking at our production sheet and our consumption, and we're working on putting a separate sheet together for that. And just obviously completing SAFER is something that's required, but not necessarily relying on that to be our driving factor for water loss, which in the past I would say would be what we use to track and everything.
Well, would you mind maybe just for all of us, by way of background, could you walk us through the two sheets that you do have there where you're giving us the report?
I'll do my best.
But by chance, do you have an extra? Oh,
Yeah, because I don't think I got.
Well, I printed mine out. We don't have any extra copies, do we?
Not the full agenda, no.
Not the full. I can lend you this. I have looked at it before.
Use my laptop, Francis.
Okay. I'm sorry?
Do you want to use my laptop? It has it on it.
I'm okay for the time being, but thank you. Yeah. Okay. So just, yes, if you would just walk us through. So the first sheet, I think, is the Felton system,
Yeah.
right? And then the second sheet's for the North District.
Mm-hmm.
And maybe just walk everybody through what sort of the numbers are and what they mean.
Okay. So first you're gonna look at water supply, volume from own sources. So this is obviously water produced from sources within our system. So that was 300 or 638 acre feet. Acre foot is 358,000, give or take. What is it?
No, it's 435 units.
Gallons.
Oh, gallons.
Not gallons.
Okay.
358,000 gallons.
But because we bill in units, which is 100 CFS
Mhm.
or 100 cubic feet, right?
Yes.
Then an acre foot is 435 unit,
Yeah,
right?
I wasn't calculating in units. I was doing gallons and acre feet, but
Okay,
yeah, it all works out to the same amount of water. So,
right.
so Felton imported 24.8 acre feet. All of that imported water came from the SLB system through IT6, like I mentioned. Oh, there you go. Thanks, Scott. There's no other connections to any other systems in our Felton system. So any imported water you see in Felton is coming from our SLB system. Water, so that was 24.8 acre feet, excuse me.
Right.
Water exported, it was 291.1 acre feet. That is water leaving our Felton system going into our SLB system. So you're gonna see there's obviously a large difference there. The reason being is our Fall Creek source is a lot more sustainable throughout the year compared to our Lion source. Right now, Lion's down to about 100 gallons a minute, but once we get rain, it's back up to 1,000 gallons a minute. So there's a large fluctuation where Fall Creek stays pretty steady up. We keep it around our maintained CFS.
Thank you,
And
Scott.
what we do is we export water to the SLV system from the Felton system to mitigate any well usage. We've talked about it before. Surface water is not only higher quality water, but it's cheaper to produce. So we were able to do this also through our emergency permit with CZU Fire, something we're working on doing through a normal permit. But it's this, so I would say since 2020, we've seen a large increase in exporting water to the SLV system, and that's helped us a lot. Our percentage in surface water production has gone up a significant amount since,
So quick question on the export, is there a single point of contact for export or are there multiple points of where flow occurs that contributes to the export?
There's just one, it's IT6 is where the export is measured for Felton.
And how confident are you about that metric in terms of inaccuracies of the?
It's not, we're having issues with that meter. I don't need to get into details, but we've had issues with it. So we're looking at getting it replaced. We try to get it repaired. Our electricians weren't able to repair it. So essentially it's been randomly resetting itself. So we've had to,
Well, nothing like random results.
but when I first started happening, I was the one that read it and I was like, is someone accidentally, fat fingering it, resetting? So I said, all right, nobody touch it but me. I'm gonna, no, and then we actually put a little code on it. It still reset itself. So there was an error in the meter itself. It's a mag meter, electronic mag meter, so it's not mechanical. I wish it was mechanical, to be honest with you.
Yeah.
Is there a schedule to resolve the discrepancy that's being observed at that metering?
As far as the schedule, we're waiting for the vendors to get back for us on prices for new meters.
Is this like a 6, 8 inch? What size are we talking about?
8 inch.
8 inch.
Yeah.
Okay.
Seems
And
like
it's
that
only
metric
one
is,
meter,
Yeah, it's a bi-directional meter.
bidirectional and single.
One single bi-directional meter. So that's how the IT6 was engineered, 2014, 15.
Gotcha.
So
seeing how those numbers can affect the overall quality of data you're presenting. to
yeah,
the-
absolutely. If the data's bad going in, it's gonna be bad coming out. So
That's one of the reasons that we want to be looking at more at water produced, water consumed, and those are the only two factors that are being looked at here.
yeah.
For the whole system,
For the whole,
whole system, not two pieces.
So when I talked about the SAFER report, and the SAFER report takes that number, and I'm still trying to figure out what it is. I have emails out to the state, and it's just
You're just not cut out to be a bureaucrat. What's wrong?
on another note, I'm trying to get rid of the whole two system thing. We submitted an application to combine our two systems into one. It's essentially one system, but the state looks at us too, right? And we've never got around to, we've had Felton since the early 2000s, and for whatever reason, we've never combined them. We've just recently pushed on getting combined, and it seemed pretty like the state they gave us a list of documents we needed to complete. We got those filled out pretty quickly, submitted them. We got the application submitted about 2 weeks ago, and still haven't heard anything. So I'm going to give them another week and then ping them. So,
Okay, good.
But it's back to the meter. So the meter going out, what we're forced to do at that point when the meter resets itself is we go to our SCADA system and we actually go through the trend and like, all right, how long was it going for 200 gallons a minute? How long? And we do the best we can, but we're not going to get fully accurate on that. You know, it would be very difficult to be very accurate on that. So
And that's where the combined system, it doesn't matter what it's reading. We
Yeah.
just know
We
how
won't
much we're
have to-
producing and how much we're sending out.
yeah, I mean, we will still read IT6 meter, but wouldn't be implemented in any type of report. You know, it'd just be
Right.
it's
Be interested to know how much is flowing,
yeah, it
plus or
would.
minus,
But
but
that, essentially, though, you really wouldn't need that meter anymore. It would just be a pump station. You know.
That would be the ideal case, because now you're dealing with intermittent data. And at the same time, you're dealing with some calibration uncertainty that the meter presents sort of as a baseline. So if you can eliminate both of those degrees of uncertainty, you're far better
Absolutely.
going down the road.
Yeah, it's been frustrating. I would say the state's also ramped up water conservation measurement a lot the last few years. So I feel like when IT6 was first implemented, there wasn't a much. You know, there was some, but it's got a little harder. So
and
So with the SCADA system, is the SCADA system for both here and Felton, or do you use a separate SCADA system?
we have the interface is combined, but there is two separate SCADA systems that are HDMI, the iFix we call it. We
Okay,
do have some trends on our, but it's essentially one at that point.
okay, same vendor,
Yeah, iFix, yeah, the RTUs, no. The
okay,
HMI, yes,
but
RTUs.
not the RTUs,
Yeah.
okay.
That's the, yeah.
That's a, that can be a source of some of the problems too, because I'm presuming there's some interface issues.
Yeah, there is a little bit for sure. We don't have all of our Felton system on our HMI, you know, so that's we kind of pulled what we desperately needed,
Mhm,
but everything we haven't.
okay,
so just, I guess, so about halfway down, you're showing water losses for the Felton system at about 341 acre feet. Is that right?
No, I'm saying real losses at 122 acre
Oh.
feet, 22.9 acre feet.
Oh,
You're probably
sorry, I'm on the
you're
spec.
probably- that's not like SLB number.
Yeah, that is SLB. Okay. there
And
we
then
go. Right, okay, 124.
there's 2 acre feet of apparent losses, or 1.2 acre feet of apparent losses.
Okay.
And I feel like that number is wrong. That number is is a lot higher in reality, but because we don't have any meter testing, they can't implement it.
So
I have to assume it's real.
So just to use the numbers that we have here, if we have 124 acre feet of losses and total water supplied of 372, if I take that ratio literally, we're in theory losing more than a third of our water.
Well,
Or I should say,
that's the thing, right? Is that
yeah.
we're only allowed to report the 1.2 apparent losses because that's the lack of meter testing that
Right.
Jesse was referring to.
Yeah.
So can I share my screen? Ben?
Yes.
We're gonna look at some, as Jesse said earlier, we are now at about 400 meters or so. Let me know when I can.
yeah, this is,
421.
I said or so.
Yeah, so just looking at what comes in versus what goes out, this is saying 34% is either being misread.
Right.
Or is leaks and other losses or something, right? So,
Correct.
okay, all right.
meanders somewhere.
So this is the list of all the meters that we sent.
Okay. Lots of things.
Does red mean something versus green?
Yeah,
Like-
red is fail and green is passed the AWWA standards. So AWWA sets the standards at low flow at 97% accurate or above, 97 to 101. Medium and high are 98.5 to 101.5. For these are all for small meters.
These are all revenue meters.
Yeah, these are all residential meters. And
Okay,
you can see that most of them are red.
Yeah, and the far right column that's pink, that's the overall fail rate.
overall failed. And,
Right.
I think two of them passed the
Two
overall.
passed out of the 421. Wow.
So you can see here. This is a summary for each model, so it's hard to see. Let me zoom in just a
Yeah.
little bit. So we have the Census SR. On the low flow, the mean percentage accuracy was 57.8%.
Okay.
Okay. The SR2, this is 3/4 inch, that was just shy of 80%. This is the SR2 for the 5/8, we're at 70.70 there. And then for some reason, two Badgers got in the mix and they tested fairly accurately.
Huh.
I don't know if those are newer meters that got replaced or what, but
What's your standard meter for purchase and
right now
application?
right now it's Badger.
I want to mention what we're switching to, the type of meter we've switched.
Yeah, so and we're going to ultrasonic instead of Newtating disc.
So if you want to just give us a 1 minute.
So ultrasonic is kind of like a mag meter in a way. It sends a pulse and it measures the velocity of the water through it knows the diameter of the pipe, so it can do the flow. Very accurate at all flows, not just high flows like these ones are. A Newtating disc has a disc that kind of has a pole through it that pushes the water around, and it kind of orbits like this. And as that pole goes around, it turns a magnet, and that magnet turns the dial.
And that's proportional to flow rate.
Right. So you can imagine as they age, that gets harder and harder to turn. So the low flows start to go away.
So the goal is over time, our meters will stay more accurate as they get older, or remain, kind of hold their accuracy as they get older, more compared to the Newtating disc.
So here's a graph of the percentage accuracy. The blue line is the Census SR, and the red line is the Census SR2. And you can see how they really start off poorly in the low flows. But the orange line is where we're supposed to be for AWWA standard.
That's
a great graph.
significantly.
Boy, that's a driver for meter selection, it seems like.
Yeah,
Well, meter replacement.
yeah.
Mhm.
And then we talked about this earlier, so I was able to do it, pull everything out, and here's the scatter graph
Oh my goodness. Oh, this is great.
for the ages.
Wow.
So you can see, I'm very this one right here. Let me zoom in. Right there, under E, that's my hero. Cause that meter's about 36 years old and is still about 99% accurate.
Whoa. Okay.
So they don't make them like that anymore.
No
Apparently.
kidding.
And that measurement of accuracy is something that was done in the field with calibration.
We actually
tools?
sent it off to a third party who
Uh,
hooks it up to his bench
yeah,
and has calibrated flows.
Yeah.
You know, a quarter of a gallon a minute, 2 gallons a minute, and 15 gallons a minute that he tested it.
yeah, that's impressive.
Yeah.
That is, and was that also then a census?
Mhm.
Your golden
Yeah,
standard?
these are all pretty much census.
Oh,
The
yeah.
only two of them were
Oh,
bad.
just two.
I'll say the majority of the meters that are tested came from our Ben Lomond meter change out, which were older meters. So it is, if you took all 30, what do we have?
7,000.
Yeah, 7,000. So if we took all 7,000 meters, I think the accuracy would be increased. We'd get a little bit better because we are taking kind of a look at more older meters. But that being said, by the time you get to replace them, all those other meters, that takes a few years. You start losing accuracy.
But with that in mind, if we had the 7,000 meters or so, and with 95% of our customers are residential customers,
Mhm.
Yep.
approximately.
Yeah.
So we're gonna do this live. Do you have the consumption numbers from last year?
Just give me a sec. Yeah.
While you're looking at that and while we're looking at your scatter graph here, this is an absolute value of meter inaccuracy, correct? It's not telling us how many meters are over-reporting and how many are under-reporting. It's just telling us how far off from nominal value the results are.
It is a weighted average. So we took 20% of the flow at low flow, 20% at high flow, and 60% at the mid-range flow. And none of them over-reported, by the way, but.
Oh, that's what I was wondering about.
Yeah. All of them, you can see none of them are at 100% accuracy. So.
Right.
So if we did the same kind of scatter graph on the remaining 6,500 or whatever meters, that would be interesting to see. I mean, this kind of implies we have an average age of about 22 years, 21 years, right?
Yeah.
Do you think that's what the district is, or do you think we have younger or older meters?
I think probably getting closer to 20 now, but we still have a long way to go to get where we want to be, which is right around 15 or so, 10 to
Right.
15
So we really have pretty aging infrastructure on the meter side,
on everything.
on everything, okay.
Consumption for 2025 between both systems was 426.3 million.
Or 20,
We're at 26.3 million gallons.
Gallons.
Can you give me an acre feet real fast? 325, 851. Is that what it is?
Yeah, he used to have numbers.
Point.
It's- Keep rolling, I'll figure.
That's about 1,300 acre feet.
1300.
That seems, oh, this is just the north, yeah, I think 1310 is what I get, but
No, that's both SLV and Felton.
it is?
Yeah.
Expect it to be closer to like 1900.
That's
Yeah.
probably like probably our production.
Okay, so if we go 1310. So what this graph, what this sheet shows is that at 1,310 sold units of water, $10.95 a unit, and that's the tier one. If we take the fleet-wide weighted average of 88%, which is what we got out of all the meters, that would be water produced at 1487, or should have been 1487. That means we lost 177 acre feet of water just in meter inaccuracy, or $845,000.
That's not good. Yeah.
Not good.
So do we have incentives to reduce estimated annual revenue loss? Is there some kind of a built-in mechanism that would incentivize the district to let's?
Well, I think so, and that's what we're working on now. We just got these numbers back, and so Jesse and I are gonna sit down and we're gonna figure out like how many, 400 meters a year. What does that cost? What does it cost staff wise?
Yeah.
Versus this.
If it costs $500 for a meter and labor, right? Then we have 6,500 meters left, so that's basically $3.2 million to replace all the remaining meters. And if it saves, 845, we basically pay for all those meters in 4 bars.
Yeah.
Which is actually a really good
And then-
payback, right?
The newer meters would have a
Per year, I
consistent-
presume, yeah.
Yeah, that's per year.
over their life because of
Payback,
their.
which is 25%.
Yeah, so what basically all the new meters are, the ultrasonic meters, is a straight pipe with 2 sensors on the side.
Okay.
There's nothing to wear down really.
Their in-service performance
Yeah,
according to the vendor.
And their
is-
batteries have even got better. So they're
Yeah.
where they used to be 10 to 15 years was the lifespan of a meter, it's now 20 years. Neptune, not to promote Neptune because it's the Badger in this district, but they did a 10-year, they would just give you the money, it was a return policy, 10 years full value, and then 10 years prorated. So for 20 years.
Interesting.
Another thing to add is, when we took over Lompico 2016, give or take, we switched over to cellular read meters. And those are the ones with the ion water. They give you the real time. And you can, those are a lot easier to look from the first of the month to the last day of the month. That's how operation does production, right? So that gives us our production numbers. An issue we're having is the consumption the consumption reads are not done at that time frame. So you're getting your readings and you're trying to compare them, but you're not reading at the same time. So you would hope over a year it would be somewhat accurate, but even if you're off by a couple of weeks, that's tens of millions of gallons. So the goal is as we right now we're about 51%, 50% cellular meters. As we're more aggressive swapping out meters, hopefully eventually we're 100% cellular read, and that variable can be taken out, basically. So that's
So the cellular read meters are consistent in terms of day of the month, first and last.
yeah, cellular read meters. You
And
can
everything
read
else is
the
like.
flow up to every 15 minutes. So
Okay.
I can take my consumption and do it from the first of the month to the last day of the month, and compare that to our production from the first to last day.
All the other meters are manually read.
Radio read or manually read. Yeah, mostly radio read.
We
Have
call
a
it
wand.
Just a monthly
You
read.
drive by monthly read, but they might be grabbing the reads on the 10th.
Exactly. Yeah.
So
Yeah.
you're not.
Yeah.
Yeah.
I have the
Why
eye on water. I guess I didn't know it was, this is in Felton, so I don't know, maybe it's because it's newer, but it's fantastic.
Yeah, it's great. That's,
I look at it every day and see what my consumption is
yeah.
and
I don't think I look at it every day, but I go to the every 15.
no, every day.
A good way to tell if you have a leak is you go to the every 15 minutes. And you just at nighttime make sure there's zero flow in that 15-minute sprint. And that will,
Yeah, no, it's great. Yeah.
that's a big variable that's kind of overlooked too, I think, is it's important when you're comparing out, you're not really comparing apples to apples when you're getting read dates at different times. So
yeah,
between the meter and accuracy, the difference in read dates between consumption and production, I think.
So do you have an estimate for how many of our meters are, say, more than 10 or 15 years old?
More than 10 years old, I'd say the majority of them.
Okay, so we've just
Even-
replaced 500, but
Yeah.
so now of that remainder, you're still saying the vast majority of those.
Well, yeah, we just replaced 500, but I mean, even on the cellular ones, they got to be getting close to 10 years.
A lot of them are getting
getting
close to
10
10 years. I would, I'm just gonna get a really rough guess. I'd probably say like 75%.
Okay. So that would maybe imply we still have 5,000 or 5,500 that are really effectively at the end of life, their end of life. And so even if we were to replace them at a 500 per year rate, that's still 10, 11 years, which I would argue economically is too long. And so we might want to look at, can we replace, 1,000 or 1,500 per year? It's a lot, and I don't know if we have the labor to do that, but economically, I think it pays for itself.
Yeah, well, it might make sense to hire
Hire-
people to do it. Pay for stuff.
Exactly. So that might be part of your analysis to look at that. Yeah. Yeah. Wow.
So I have sort of a question that is related but not exactly the same. In some of my other work, I do a lot of cybersecurity assessment of meters and equipment, electrical meters, not water meters. But with the SCADA system as well as the metering system that you've got, how good is your cybersecurity? And I say that because increasingly with AI and, somebody is just pissed off and wants to do
Yeah,
some
absolutely.
damage.
I would say SCADA wise, we have firewalls. The Badger site itself is open internet facing. So I can't really speak on the Badger side of that. That's a good question. But, Springbrook is protected by our firewalls. Scotty might be able to help out.
Well, Springbrook has a two-factor authentication that's required to
Yeah.
get into it. Badger, I do not know about.
Yeah.
That might be something worth checking out.
Scotty, IT analyst?
We have multiple logins for each individual user. They don't have the same username and password for every interface that they're in. Their email is different than their login to their computer, and the login to SCADA is different than their login to their email and all that stuff. So try to keep it a little bit separate.
Did
Yep.
you see the apparently a couple dozen small water districts in Missouri were struck? And
I know it's happening more and
yeah,
more.
yeah.
And I believe
Yeah.
someone mentioned those were open internet, right?
They're open to the internet, and
Well, open internet doesn't really mean the
one
same
of the
thing.
biggest things, and I'll say this for the world, the best way to stop it is have two-factor or multi-factor authentication.
Yeah, it's the backdoor entrances, the vendors coming in, something else
Exactly.
coming in.
That's right.
That's
That's
where
where you get
the
it.
danger
You
is.
sneak
Yeah,
in, right? Not coming face on, but
right.
through a
it's-
back door that a vendor put there.
Right, right. That's
Backdoor is
often,
basically evil.
There we go.
Yeah.
Yeah.
I've
no,
had
that's
this conversation in the electric utility industry,
right. Yeah.
and I heard a vendor say, well, we have a backdoor so we can go in and do a firmware upgrade or whatever. And I said, well, I know a vendor that absolutely forbids any developer putting a backdoor into this box. It all
Yep.
comes in the front door and that's it.
Yeah.
Whether it's you or a contractor that you enable to do this. So if you come across equipment that has a backdoor, then for me, that's a red flag.
Yeah, that's a good point.
yeah, well, it's
Yeah.
also how you use, what policies you have in place for using any kind of backdoor. Is it one where the vendor just can come in at any time because they happen to have the password? That's one type of backdoor, very unsecure. And the other is, okay, there's somebody sitting there in the, next to the system, and the vendor is allowed to call in, and they're watched as they do something, and then they're shut out when they're done. And so, because sometimes the vendor really does need to get in there unless he's gonna travel thousands of miles to, put one small patch in. And of
That's how
course,
we did
patch
it.
management's
Yeah,
another,
that's how we did it.
area.
It was, they would call us and say, well, we need to log in, and then we would set it up for them.
No, it's interesting. We actually just recently had a meeting, Scott, Jason and I, with the EPA Technical Assistance Cybersecurity, and they basically we answered a bunch of questions. They're giving us the assessment and, areas where we can improve and whatnot. We're
yeah,
Did you get
that's good.
a green pass or a pink? fail?
in the middle. I just got a C plus.
See.
We're in progress.
Yeah, that's,
Okay.
Adding multi-factor
Multi-factor.
would be a good one.
yeah,
Right.
multi-factor.
That would help our score a lot.
Yeah. So there are lots of ways, and you have to pick up the highest risk areas first, and then so you can concentrate on those. And then the lower risk ones later on, and it's of course, something where just like the meters, you have to keep doing it over and over again.
Yeah.
Yeah, and
That's
I guess, well, go ahead.
No, as far as I guess call it hacking in the meters itself and change. I couldn't tell you. That is an interesting thought, though. Someone could, I guess they would have to hack into Springbrook, right? After the number was.
They would have to hack into, well, it depends on where in the process it is, because I'm assuming it's done the same way with Badger as it was with Neptune, but basically the route is uploaded to Springbrook, and once Springbrook has it, then yeah, it's protected. It's in the cloud. It's behind two-factor authentication. You're not getting in there. So, while Badger still has it, I don't know, to be honest with you. I'm assuming they're in the cloud as well.
Don't know.
I'd have to ask Chelsea. To be honest.
One thing that's interesting is that with these hacks in Missouri, it wasn't for ransom, which you could certainly understand. It was just to create chaos,
Mhm.
right? And so, and I guess another piece of it is from a cybersecurity point of view, is to make sure that it's one thing if you just bring a system down or whatever, but if you can actually hack it so that you're closing valves and turning pumps on and you're now breaking infrastructure, then that's obviously a much more serious.
Yeah, I mean,
Right.
public health would be the most serious, and then
Right,
that
yeah.
ties into public health a little bit, but
That's right. Well, that's true. Messing with the water treatment process,
Yeah, for
how
sure.
much of that can be done remotely and
yeah, absolutely.
played with. So those are, maybe this would be a topic for a future, I know at the end of this, we're going to talk about,
Cyber
future,
security, but
yeah, but we bring up the, cybersec stuff.
yeah, no, I don't want to get into too much detail. I'm not really
Yeah.
super comfortable talking in public, talking about exactly some of our vulnerabilities, but yeah, absolutely, they're out there.
Yeah, no, good. Any other thoughts, Bill or Greg, on the water loss audit info? So Jesse, so it looks like a big chunk of this is lost potential revenue that is actually water that's being delivered to a house, but they're not being charged for it. what's your guess as to how much is now main leaks and
Yeah.
breaks and that kind of stuff? Because that's the other piece of it, right?
So we do a monthly leak report. I was just looking at the July report. You know, it's you have main break, I call them main break leaks, and then we have processed water. This is water that gets it's our instruments used, and they're just basically dumped on the ground. They're not recycled. That's a lower number, but I would say it's somewhere between, it varies a lot, obviously, but I've seen it as low as like 90 to 100,000 a month, and I've seen it as high as about 1.5 to 2 million a month.
So gallons.
Gallons. This is based on
Oh,
staff's estimation on how long the leak's been going, which is hard to guess,
okay.
and what the GPM is, which is a little easier to guess, but obviously you're not going to get it exactly right. So it
So
is an
that works
estimation.
out to about a third to 5 acre feet
Yeah,
a month.
exactly.
Okay, so even times 12, we're still 25 to 50 acre feet per year,
Which
which
with
is
actual main breaks.
actual main break.
Yes.
Okay, that's better than I would have thought. I mean,
Yeah,
I don't know, but
To that end, though, we are putting out an RFP to do leak detection. It should be hopefully out this week or next week.
oh, good. Okay, good. Yeah, because it's been how long since the last one?
3 years.
3 years.
3
Okay,
to 4 years.
It's time. Yeah.
We're going to look at some areas that weren't looked at. We didn't do the whole system 3 years ago. So when we look at our north system moving south from Brookdale south, a lot of that's already been detected. I think actually all of it over the last 5-10 years has been looked at,
Okay.
but we haven't.
And for leaks that we have, I know we were sort of trending about 30 a month. Is that right?
No, it's closer to 15. I'd say.
15 now? Okay, so
I think it was 21 in July.
21. Okay. So
Way to split the middle.
So
I'm
those,
18, but-
those are known leaks, or is that?
Those are known leaks. These are leaks that are service orders created,
Yes,
and
yeah,
we go on site. So I have the numbers right in front of me right now. January we had 11, February we had 3, March we had 16, 12, 15, 13, and July was 18.
and how do you get to know about when there's a leak? Is it,
Usually it's a customer. Honestly, it's
you get a
usually,
phone call?
but there's other ways to find it. We'll see on,
I got an email last night.
emails. Customers are our best.
And seeing a wet spot?
A wet spot.
Uh-huh.
Another thing we use is SCADA. We use SCADA. We have operators analyze SCADA. Our treatment operators, they do it in the morning and then at the end of the day, and then in between if needed.
Sounds like an AI application.
Yeah. And so we can
Yeah.
Well, that's the thing that's what SCADA, a newer SCADA system would do for us.
Mhm.
It would be analyzing the trend of the water and saying like, hey, you set that threshold of like, if you see this drop too much or whatever, it'll let you know, hey, there's a leak, a possible leak going on.
what we do, we would see a decrease in the rate of rise and an increase in the rate of fall. So that would tell us it's taking a lot longer to fill it up and water's coming out a lot quicker. Let's drive around scenic and look for a leak, which is something we've done a lot, so that is another way we find leaks.
Do you find leaks using acoustic methods?
Yeah, we have, we call it ears, but yeah, basically,
Geophone,
I think that's what it is. Yeah, geophone. I've heard it referred to as that, but yeah.
a
You
stethoscope?
walk that at night.
Scope. Yeah, I think it's
Scope,
scope.
yeah.
Yep.
With the leaks that we have been addressing here, I guess in the last half year, is there any trend? I mean, like in either type of pipe or age or location, or are they just everywhere?
I would say most of them are old galvanized lines, a lot of 2-inch.
2-inch.
We do have some of our bigger main breaks have been on our asbestos lines. They last a long time, but they're kind of brittle, so it's not great for this area as the ground moves around a lot.
Yeah.
And a lot of our, some of our larger mains are asbestos, so those would be our larger breaks.
Are the pipes broken or is it like a gasket that?
No, yeah, there's like a crack.
Okay.
A lot of
Natural
them,
crack.
there's a crack on it, yeah.
Okay.
Sometimes completely sheared off, but usually it's like a crack, that grows.
So like a longitudinal crack, or you think is it actually around its outside?
Mostly, but my experience, but they're both.
Oh,
I think the biggest leak I've seen in my experience was with a where the pipes were butted together. It was a butt fit. And there's like some kind of a material that is put in, and then lead is, pounded in, and that holds together until they come apart, and then you've got a huge mess.
Yeah, when they completely separate, obviously, it's a wide open leak.
It's a big,
Similar to that, what we see, we call them flex couplings. So a piece of pipe can go on each side, and it has a little bit of movement. So the older ones on the 2-inch Galvia, we're finding that they're kind of separating from those pipes.
Got it.
So that's one trend I'd say we're seeing. Location wise, all over. Lompico has a decent amount. Brookdale has a decent amount. Felton,
And given the numbers from Felton,
what's that?
well, you were gonna say Felton looks small or?
The numbers are lower, but of course there's less main.
Right,
So-
yeah, it's only 25 miles of Maine and Belton.
It's not as many in Felton. I'd say
Right.
75 to 8% are in the SLB system.
I mean, that's certainly where maybe an analysis, AI or whatever, would possibly help us prioritize as part of the CIP plan. Which sections of pipe do we say, let's go after these first?
Yeah, and that's something we look at when we're choosing these pipeline projects. We're looking at under fire flow, and we're looking at how many main breaks we're having. So a good example is when we're jumping in is the railroad project. It's 1.5 inch main with 34. How many customers on it?
I'm not sure how many.
Yeah, maybe like about 30, give or take, customers, which is crazy.
Yep.
And if you walk down that road, you see patches all down that road and all the guys know they've been out there a lot railroad. So that one was a pretty easy one to identify. Let's
Right,
replace that.
to replace it, right, yeah, very good.
Are you losing any galvanized pipe to galvanic corrosion? Electrical current?
Not sure how we could determine that. I mean, usually what we see is we just see corrosion. We don't know if it's from the soil or some type of current.
So when you pull a residential meter out to replace it, are there any considerations for the crew in regards to a possible electric shock from a voltage differential between the service pipe and the residential connection?
I wouldn't say it's normal procedure, but we have in the past where you have you feel a little shock. It's a low voltage shock, and at that point they'll put a jumper on. So yeah, it has happened in the
You're
past.
probably losing some pipe as a result of
Yeah,
that.
imagine some of the smaller service line pipe. Yeah, the 3/4 inch, 1 inch.
Yeah, I guess when you replace a pipe, I assume that you can look at what the cross section looks like in the pipe and just see
Yeah.
how much of the original metal's still there
Mhm.
and how much is gone. And that would certainly maybe feed into, what's a priority to replace. But is there a way to actively galvanically protect a pipe?
Yes.
Yeah,
We do that with some of our tanks. I don't believe we do it with any of our.
with any of the pipes, yeah. So they're just exposed. Is it just too expensive or?
No, why it wasn't done in the past? I mean, I'm assuming now we're putting plastic pipe
Plastic
in.
in?
Oh, we're putting a lot of ductile iron in. So I mean, I don't know. Did you guys do it all over Express?
We didn't put ductile iron in it.
Oh yeah, good one. I don't know. I don't think it's poly. I'm gonna just without really knowing. It's probably not industry standard to give galvanic protection. to your
Ductile
main.
iron may be a little different, but I don't know. But the only time we ever used any sort of cathodic protection was when we did our CMLC pipe. So that's just basically cement mortar line coated, and it's just about an 1/8 inch steel pipe which has cement coating on both sides. So that has some cathodic protection on it to protect the steel, but we didn't use a lot of it.
No, like sacrificial metals that are attached,
Yeah,
which
so
will
we
be
just
given
have
and
it
taken
as
first.
sacrificial anode that
Right.
but
Oh, I see.
Yeah.
That would be included. Well, I mean, maybe I don't know how much ductile we're putting in, but maybe at least ask that question. If it helps prolong the lifetime. Yeah, I don't know.
It's interesting.
Yeah. Let's see,
yeah, we had very aggressive soil. Everything there's aggressive.
redwood trees. Acidic.
Yeah,
Yeah.
highly acidic here, yeah. Yeah, yeah. Um, any other thoughts, questions? Covered, losses, main.
I'd like to come back to the point that Francis brought up about cybersecurity, because I think that this is really, and you're addressing it with two-factor authentication for login methods. And at some point, it'd be nice to know, given available approaches to helping assure cybersecurity, as you kind of do a self-audit or an update as to what, not to talk about vulnerabilities in this meeting, but to let us know that, all right, we've taken some time to examine this.
I think we can report back to the meeting, what in general, what measures we're taking to make sure that cybersecurity is being done
Yeah, it's
without
just,
being specific.
exactly.
But you said that there was some kind of, not audit, but at least questions
Yeah, that was,
related to that.
oh, no, yeah, it was through the EPA cybersecurity technical assistance. What
Right,
that is really is it's assessment of our district. And then the goal is they take it's the first step towards grant funding. Really, that's
okay,
that was the purpose of that meeting was, all right, we want some grants. There's money available for cybersecurity. All right, what do we have to do? Okay, you have to go through this assessment, and that's where we are right now.
okay, because that I think in itself could be a very useful source of, okay, you said this sort of got a C plus
Yeah.
rating.
All
Very,
the stuff
very
we have-
common. I mean, that's
Yeah.
pretty normal. But that would be then, okay, here are the areas that maybe there could be some grant money to help with and so
Yeah,
forth.
absolutely.
So I think that could be very relevant to get a better handle on exactly the areas without getting into the sensitive stuff, because that's what security is all about.
Yeah.
But at least know that, hey, there's an area here, maybe.
Where are we?
You need better firewalls, you need better training of personnel,
Yeah, absolutely. And tying that in with,
Yes.
we're looking at overhauling our SCADA system as well.
Yeah.
Whether
Yeah.
that's upgrading the system we have right now or a full new
Yes.
system.
Security
Kinda.
by obscurity is not a good approach anymore.
Well, it sounds like the cybersecurity is a good topic for a future meeting, so.
Yeah, I think that'd
I'll
be-
leave it up to Jason and
That'd be a good
the
topic.
staff to do that. Yeah, that'd be great. Are there any more comments on the water loss or leaks, anything like that for us here?
No,
No,
that's,
no, no one online, Scott?
would be nice to have a little more accurate information.
Yes. So I guess I would certainly encourage just looking at the economics of this. If the numbers that are presented are at all accurate, the more meters we can replace every year, we're actually saving money. So, I mean, if we could actually replace 6,000 meters in the next year, it pays for itself.
Yeah, I think that's what it comes down to.
Yes,
Mhm.
so you just got to schedule,
aggressive.
yeah,
Yeah.
who can do the labor and train them and or whatever, part of that whole process. Okay, good. All right, well, if there's no further comments and no public, then I think we only have one other topic, right? Future agenda item.
Yes, thank you, President Russ.
Okay,
So at the last meeting, we discussed bringing back the district's power usage. So on the table, we have that tentatively scheduled for December. Another topic that I think Director Smalley was interested in was the water production cost analysis. And what does it cost us to make water from surface sources versus wells?
I'll note that the water production cost analysis is something I bring to the quarterly reports for the last two reports I've done. And so that will be kind of mirror what you'll see in that report.
okay. And if I could just add a little
Yeah.
sidebar to
Yeah,
that.
anything you would like that, because I'm trying to wonder what more can I bring to that meeting than just this is what it costs per.
I think you can do a very simple cost analysis to how much does it cost to raise 1 unit of water 100 feet? Because that's what our pressure zones are divided into. And so it's really just the energy required to lift a 100 cubic feet of water, 100 vertical feet, and include the losses due to pumping inefficiencies, right? It's not going to be 100% efficient. And then as a piece of that, also include then the life cycle costs of what extra pumping equipment there are. Because I have a feeling that our pressure zones actually are fairly, that there actually is some real cost to those, especially when something's up 500 feet compared to lower altitude, lower elevations. So that would be good just to kind of have a ballpark number that we can all play with, you know. Because I know you had presented some numbers a time or two ago, right? About variable chemical treatments and stuff.
What did I call? I call them operating costs or whatnot. It's basically fixed costs that we don't have control over. So that's PG&E and chemical, really, is what it is. And I compare that. How much is it per gallon for surface water, and how much per gallon for groundwater if you take in the PG&E and chemical costs.
Chemical costs. Okay, good.
It might also be interesting to see if we're maximizing production from Felton and pumping it north versus if we have production from Lion and we can gravity feed
Or
south.
Peavine.
And yeah,
Right.
Peavine.
Peavine.
Exactly.
Gravity,
That's 100 acre feet right there.
We've actually done that. We've
Yeah.
looked at what it costs to make water at Lion and what it costs to make water at Kirby. And you know, Lion's obviously gonna be a lot cheaper because it's all gravity fed.
All gravity.
And then
Yeah, that's huge.
depending on where the water is being produced
Yeah.
and where the water is being consumed, if you have to travel through multiple zones to get to, say, the end of Zayani or up until Lompico,
Right.
you know, that might be the most expensive water at the
Well,
top.
it's also the time of day that you need to pump it. If you have to pump it during peak hours, it's going to be more expensive. If you can pump it overnight,
Right. And
then
have it
it's a
stored.
significant drop.
Well, it ties into our time of use. We talked
Time
about
of use is a big issue, yeah.
So that'll get us to look at the storage capacities and how much.
Yeah, there's
So-
definitely some
storage.
tanks that we could, not pump during the peak, and there are some tanks where we have to,
Mhm.
basically. So as we upgrade our tanks though, and get rid of these smaller tanks and get larger tanks, obviously we'll have more flexibility with that.
Over time, yeah.
Yeah.
Highland's a great example. That's tanks that filled all the time. Or actually, Swim's even a better
Yeah.
example. Swim, that thing's turning on every 20 minutes, and
Wow.
and we have a lot of comms issue right now. We've had, guys are a lot of staff time checking it manually, running it manually because it's an old AT&T copper line. The tank's small and leak, so if you lose comms there, you don't have a lot of time before that thing goes dry.
Wow.
So, that's going to be huge, replacing swim tank.
All right.
The-
Okay, good.
So I was
Yeah.
looking at the SCADA for next time for October. Well, not next time, but October or November if it's committee is in October. I would really love to see more about cybersecurity for the SCADA system itself. I mean, I know there's a lot more cybersecurity personnel and all sorts of the metering system.
Mhm.
But cybersecurity for the SCADA system would also be very useful to know more about and make sure that the capability is there to upgrade it to better cybersecurity, because I'm sure it's not at the moment.
And then we were thinking about bringing an update on the capital improvement program, where we are with the projects. And if there's anything else that the committee is interested in discussing, we'd love to hear from you.
What are you thinking in broad terms for the capital improvement update? What would,
It would be, so based on the board approved budget on the capital list, where are we on all the projects and where we're going?
it's like, so that would include like percent completed? Would it be that kind of detailed and
Yeah,
budgets for it?
Gantt charts.
Yeah, okay,
And how much money we've spent, what we've got done, if we hit a roadblock,
good. Yeah.
what's the plan to get it running again if we're not actively working on it, kind of thing.
So would this also include maybe putting in the new meters faster? It's not capital, but it's
It is included in the
capital,
Yeah,
okay.
actual project.
Yeah, that
But-
would-
Because at the moment, I gather there's just a certain rate that you're putting in the new ones. Sort of a what if set of scenarios.
Even if we go.
and on the
even if we
return on
said, let's do
investment.
500 a year, even if that was the case, we're just gonna do 500 a year, that's still a capital project that we just. do.
Okay, so it's still capital,
Still
even though it's, yeah,
Yeah, because it has
basically
more than a
operation.
1-year
It's
life.
got
I
meters,
believe
yeah.
on the last approved budget, the Ben Lomond meter change out is a line item, and that was a grant that the district was awarded. And then there's general meter change outs. I think it has a nominal budget, but it's not necessarily tied to any program where we have a rate that we're trying to do. But if we needed to change out a meter, we have money to do that.
Yeah, because it may be beneficial cost wise to do it faster. It sounds to me,
I think it
if
is.
nothing else, just getting more accurate information strikes me as being worthwhile.
Yeah, I would agree. And so maybe as part of the CIP update, maybe look at, meter replacements of 1,000 or even better, 1,500 a year, if that's possible. What would we have
What
to
would we
do?
have to budget?
What would we have to budget and how would we do it?
Yeah, I'm gonna run, I'm, like I said, I'm gonna take the number, I'm gonna run it and sit down with Jesse and talk about how many a year, what's the manpower look like. And we'll go from there.
Exactly, right. Yeah. Is that, are meter replacements, can they be done any time of the year or is there really certain seasons that it's better to anytime?
I'm sure they'd rather not do it in the rain, but.
Okay, yeah, but, okay, we can't. All right, we talked about power usage, okay, yeah.
Just as a side issue with the part of the capital improvement review process coming up and the meter replacement, is there a way to prioritize which meters get replaced sooner versus those later? Like if you've got this winner that's 100% accurate for 30 years, it seems like take that off the table for now, right? But if you've got a bunch of losers, you can focus on that
Yeah,
cloud.
I mean, I would,
Start
I
with-
think,
I don't know how you do that operationally, but it would seem like if you can
I
prioritize.
would target old meters first and just go through.
We think, when we get for Ben Lomond meter, it's a good example. We got a grant. They didn't tell us what meters to change out. That we
Okay,
decided that in-house, and that
Good.
was based
Good.
agent meters, where are we having, basically where are the most non-cellular read meters?
Yeah.
Easy way to look at it.
Yeah.
And it's also customer service looks at routes. So, I
oh,
trying to get it out of
difficulty
my
to
millimeter.
read.
But like, oh, we're doing route B right now, so let's make sure we knock all those out because,
Yeah.
Makes sense.
Yeah,
that customer service is coming on
The
that.
easiest way to do it is
Perfect.
we're gonna do this street today,
Mhm.
you know?
Perfect.
Makes sense. Do any of us have any other suggestions for other future agendas? So we're
I'm
addressing,
happy with what we've talked about here.
yeah, no, this is great. But we can,
I'd like to bring up our tank inspection and coding schedule we're developing.
okay. As part of the CIP or
Yeah,
separate?
well, there are projects there are tank coding projects identified in the CIP.
It will be in the CIP,
Okay,
but we definitely need to have a schedule.
okay, yeah, special attention, yeah.
Yeah.
That's true, because it's
Well,
a huge number and we have a lot of
Well,
things.
right now, yeah, we don't have a tank inspection / cleaning schedule. And this is something where the divers go in with the tank online and they're able to vacuum it out and everything. So
Wow,
there's that should be done. What is it? 5 to 10 years. 5 years seems pretty aggressive, but yeah, 5 years. And then there's the actual recoding of tanks that we know are past its life of recoding. So right now, the strategy we're taking on, we don't see a huge benefit to just doing a general inspection and cleaning of a tank that we know is going to be recoded in the next few years. It just doesn't seem like a waste of resources. So we're separating which ones are like, all right, these are 10, 15 years away from being recoded. Let's start getting those inspected.
Yeah.
So and Garrett's already produced a list and we have a good idea. We don't have a set schedule.
Do you store raw water or treated water?
Treated water. Yeah. No raw water.
We did just have a cathodic protection inspection on the tanks.
Yeah, we have some cathodic protection on a few of our tanks. Yeah. A lot of our new tanks we're putting in are bolted steel and it does not work with cathodic protection. You need the welded steel, so we're obviously not gonna be installing it there, but
And I'm trying to remember kind of a ballpark cost for either the maintenance number for a tank or the recoating for a tank. Do you?
So we have some information about Brookdale tank. This is a tank built in 1971. It holds over 720,000 gallons. It's a welded steel tank. And due to the age of the tank, we're anticipating the repairs being on the order of around 800,000.
Guys, this is not on the agenda.
Yeah, okay, so, okay, well, I was just curious about it, part of this. But you're right, it's not on the agenda. Okay, so that's certainly a significant number.
I would say that's a little higher than.
I think that's a little higher, I hope, yeah.
I mean, just because the condition of Brookdale's so poor,
Right.
Yeah.
And it's so big.
closer to the
It's
half
big.
million.
And if you send a diver in for more routine maintenance, what kind of ballpark is that?
Been a while since we've done that. I want to say it's probably somewhere between 10 to 30,000.
Okay, last time we did it was about $15,000 to do diving tank.
Okay. All right, okay, just really curious, okay. So the recoating's a big deal.
Yeah, it is. We have to take it offline. It's operational challenge.
Yeah. Okay. All right, good, so that's a good one that you just mentioned. Any others that you can think of? Garrett,
I
anything?
populated the list.
Yeah, okay. And you left off the ones that are really tough, and you're leaving it up to us to ask you, right? Okay. All right, well, if there's no other thoughts, any public hands, okay. All right, so I guess we move on then to the informational material, our last minutes from last month. Are there any edits or corrections to that from any of us? Okay, we'll let that stand. I think that wraps it up. So if there's no others, we'll adjourn this meeting. Thank you all very much.
Thank you.
Thank you, Jesse and Garrett. Appreciate your